Question is, what volume of oxygen would be required to burn completely 400 ml of acetylene, that is C2H2. Also calculate the volume of carbon dioxide formed. So it's very simple reaction. Always do remember that whenever the hydrocarbon burns or reacts with oxygen, they produces carbon dioxide and water. So here we have C2H2 plus oxygen. It will give you CO2 plus H2O. Now the simple thing, we have to just balance the reaction. Okay, now as we have on the right side we have 2 carbon, so we will multiply RHS by 2. As we have 2 hydrogens, we have 2 hydrogens already, so reaction is balanced. Now talking about the oxygen, we have 2 oxygen over here, we have 2 to the 4 oxygen here and 1 oxygen over here, that is a total oxygen. In the right hand side we have a 5. So how to balance this equation? Okay, so on the LHS we will multiply oxygen by 5 by 2. The most of this question arises, sir, why 5 by 2 and not 5? So reaction, the answer is very simple, dear. We require 5 oxygens, okay, and not oxygen molecules like 5O2. We require 5O and not 5O2. Okay, so basically O2 means 2O. O2 means 2O. So if I am saying 5 by 2 O2, that means it is 5 by 2 into 2 times O. Okay, according to this, it is this. So this 2 and this 2 gets cancelled, and that means I am nothing but I have written 5O. Okay, 5 oxygens. Okay, now, but the thing is very simple, sir, we cannot write the fractions in the chemical reaction. So what should we do? So the answer is very simple, multiply the whole equation by 2. So if you are multiplying whole equation by 2, we will get 2C2H2 into 2. So this 2 and this 2 will get cancelled, and that's what our motto is, 5O2. 2 into 2 will give you 4, and here again 2. So now you can see the reaction is completely balanced. 4 carbons, 2 to the 4, here 4. Here we have a 2 to the 4 hydrogen, 2 to the 4 hydrogen, 10 oxygen, 4 to the 8, and 8 into 2, 8 plus 2, 10. So here we have a balanced reaction is balanced. So now the important thing to multiply. So 2 into dash, then 5 into dash will give you 4 into dash is 2 into dash. So now we just have to fill the flanks. Okay, so as the next question includes that what volume of oxygen would be required. So we have to find the volume of oxygen required for the complete burn. Okay, it is required to burn completely 400 ml of acetylene. Okay, so volume of acetylene is given as a 400 ml. Okay, 400 milliliter. So this answer is very simple. 2 into x is equals to 400. So x is equals to 400 by 2. That means x is equals to 200. So we have to fill 200, 200, 200 and 200. So answer is very simple. So volume of oxygen required for the complete burn of 400 ml of acetylene is 1000 ml. Okay, so answer is very simple. And also they have asked us to calculate the volume of carbon dioxide formed. So this is also very simple. 400 200 will be 800 ml. Okay, if they have asked about the volume of water, then water is also simple. 2 into 200 is 400 ml. Okay, so we have to write the answer. Volume of oxygen required for complete burn of C2H2 is 1000 ml, and amount of carbon dioxide formed in this reaction is 800 ml. Okay, so I think you understood the explanation. If not, then repeat the video again and try to understand.